Okay, so we have with us tonight, we have Dr. Brian Miller. I know him as Brian. I've known him since he was a college student, working on his PhD at Duke University, where he got a wonderful degree, PhD degree in physics. And so I'm going to spare you the details of his thesis. It was pretty incredible when he told me, and also yet simultaneously incredibly boring. So anyway, we'll spare you from that. Brian came to faith in Jesus. He grew up in a denominational church, but as he was in college, he actually lost whatever faith he had. Yet, listen to this, through the study of science, he came back to faith. So that was like a reverse from what a lot of us often hear today. He presently works, he's worked with in many great positions as a thinker, a researcher, a writer, a speaker. He's been coming in and out of New York City for 15 years or so, about once a year or so. He also has a fascinating presentation and seminar that he provides on the shroud of Turin. And we'll save that for another day. And that he convinced me of the shroud. This is like, it's crazy. And we have a lot of catching up to do on that because I've been exposed to the leader of the STIRP project. Yeah, I know, it's amazing. So, and he's a nuclear physicist, so you get on well with him. So anyway, tonight, this is a God Talk. It's going to be brief. We will have time for questions, though, at the end. But just to start out the questions and answers, and let me mention this last thought about Brian. Brian presently works for an organization called the Discovery Institute that's headed up by one of the great thinkers of the world named Dr. Stephen Myers. So well done in landing a position with the Discovery Institute. Not all of us can say that. The focus of the Discovery Institute is intelligent design. So he'll be talking about that tonight. So let me ask you three questions before we get started.
Okay.
Question number one. And you have to just say whatever comes to your mind first. What do you think of Charles Darwin?
Innovative but wrong.
Okay. All right. Number two, does the book of Genesis create any conflict with science?
If you interpret Genesis properly, it's in perfect harmony with science. In fact, it's interesting to note that Genesis stated that God created the world and everything in it. Scientists for many years believed that the universe was eternal. So with the advent of Albert Einstein and general relativity, people realized that science points back to the book of Genesis.
Excellent. Einstein? Well, that's pretty cool to know that. All right, here's my third and final question, and then we'll get into your talk. Exactly, precisely, how old is the Earth?
Oh, wow. That's more controversial. It's debatable among Christians. So many people feel that a proper interpretation of Genesis means it's about 6,000. Other Christians feel that a proper interpretation of Genesis would allow for it to be very old. Currently, the science points to the universe being about 13.7 billion years and the Earth about 4.5 billion years.
So my question was precisely how old is the Earth? It's the first time I've asked you a question where you did not have a precise answer. Anyway, welcome aboard.
Thank you.
Glad you're here. Let's welcome Dr. Brian Miller.
Thank you. It is really a pleasure to speak for you today, partly because, one, I love your church. I've visited here many, many times, probably when some of you were about 5 years old. And also because this is one of my favorite topics, because I'm talking about the origin of life. And this is really significant, because one of the most important questions people ask are, am I here because I am created by God for purpose, or am I simply an accident of nature? And what's happened for the last few hundred years is most scientists in the academy have said that we're simply here through the blind forces of nature. And that's what science says. But what's happened over the last several decades is science has come in, evidence has come in to demonstrate that the origin of life is impossible through a blind, undirected process, and it shows clear and undeniable evidence of intelligent design. So the origin of life, when you study it, is a lot like when Galileo looked through his telescope. And when he looked at like the moons of Jupiter and looked at other evidence, he realized that the geocentric view of the world was coming to an end, the view that the Earth was the center of the universe. In many ways, the origin of life is the same way, because people that look at the evidence honestly recognize that our view that all that there is, matter and energy, time and space, is false. That's not all that there is, because there's a designer and intelligence outside of time and space that created us for a purpose. That's why it's significant. So what I'm going to do for you is take you on a journey and talk about the basic arguments for why the origin of life cannot have happened through a blind process, and two, why it shows evidence, clear evidence of design. So the talk is entitled The Origin of Life, Thermodynamics, and Design, because what I'm going to talk about is really from a physics perspective. So I have a PhD in complex systems physics, and it's really the physics that has defined the issues most clearly with origin of life. First of all, let's talk about the history of the study of the origin of life. Perhaps many of you have heard about the Miller-Urey experiment. That's something that's in your textbooks. It talks about the prebiotic soup. And this is sort of the high point of origin of life, because what happened was some scientists took methane, ammonia, hydrogen, these gases, put them in basically a container, shocked it with electricity, and produced some of the amino acids needed for life. So this was hailed as a major breakthrough in origin of life research. Well, ever since then, it's been all downhill. Because what people realized is that the gases used in this experiment were not the actual gases on the early Earth. When you repeated the experiment with the actual gases, what happened is you only got maybe glycine and maybe another amino acid, but most of it was just trace amounts of the molecules needed for life, and the rest was materials that were completely useless. In fact, even if you look at Miller-Urey's original experiment, what happened is they produced some of the amino acids, the building blocks of life, but most of it was produced as tars and other chemicals, and those other chemicals would have cross-reacted with the organic materials, the amino acids, such that it was a completely dead end. In other words, from this experiment, what you get is simply useless tars and other materials that could never lead towards life. Well, as you go on, what's taken place is people attempted very simple origin of life experiments. They would never really get the building blocks of life in large quantities. So there was a shift in origin of life research where experimenters would use very, very complex chemical methods of multiple steps, of changing the ingredients, of changing the chemical conditions. And what happened is they were able to make perhaps a nucleotide, but only through incredibly elaborate procedures. And what happened was an origin of life researcher named Robert Shapiro basically critiqued this. He said, the analogy that comes to mind, and this is in describing these experiments, is that of a golfer who, having played a golf ball through an 18-hole course, then assumed that the ball could also play itself around the course in his absence. He had demonstrated the possibility of the event. It was only necessary to presume that some combination of natural processes, earthquakes, wind, tornadoes, and floods, for example, could produce the same result given enough time. So the idea of all the origin of life research that produced anything useful had to rig the experiment to make it happen. In fact, another professor, James Tour, is one of the top organic chemists in the world. And he looked at all the origin of life research, and he talked to a lot of the leaders, and this is his conclusion. He said, from a synthetic chemical perspective, neither I nor any of my colleagues can fathom a prebiotic molecular route to the construction of complex system. We cannot even figure out the prebiotic routes to the basic building blocks of life: carbohydrates, nucleic acids, lipids, and proteins. Chemists are collectively bewildered. Hence, I say that no chemist understands prebiotic synthesis of the required building blocks, let alone assembly into complex systems. Let me translate that into English. Basically, the origin of life is a dead science. They have not been able to even explain how the most basic building blocks of life could be produced. Virtually everything you read in your textbooks about the origin of life is either extremely exaggerated or outright false. It's more of a secular mythology being presented, not facts. But even beyond that, even if you ignored that problem and imagined that you could produce all the building blocks of life that you wanted, another problem is how do you localize all the basic building blocks of life? So if you have, let's say, a cubic meter of water, that would be like a small pond, very small pond. And imagine that a cell membrane formed in that pond, the perfect cell membrane. It's sort of the staging ground of life. Now imagine that you also have a perfect protein that forms. So that is going to basically be, a protein that can be used in your cell. The time it would take for the cell membrane and the protein to make contact would be on the order of millions of years. That's 1 cubic meter of water. So that protein would break down long before it would even make contact with the cell. Now, the bigger problem is that if you look at the origin of the basic building blocks of life, they require different environments, different chemical conditions. So they have to be produced in different locations on the Earth. So in order to get the origin of life, you have to get these materials that were produced in very distant environments to come together inside of a cell membrane. So you're not talking about 1 cubic meter of water, it's more like 1 billion cubic meters of water. So just getting the materials together is a physical impossibility. But I'm not even going to address that. I'm going to assume you've got everything you want in a test tube, whatever you want. Again, even there, what I'm going to show you is the origin of life is not possible. We'll first talk about the issue of probability. And the question becomes, if you've got, let's say, all the amino acids, all the nucleotides, whatever you want, how likely is it for these different molecules to come together to form your cell? Well, there is a famous physicist named Fred Hoyle, and he estimated that the probability of a cell forming is on the order of 1 chance in 10 to the power of 40,000. That's a 1 over 1 with 40,000 zeros behind it. Let's say it's really, really small. And to use the analogy, it's kind of like if you've got a tornado going through a junkyard and throws all of the pieces of the junkyard up in the air. It's a chance of a 747 airplane coming down, filled with gasoline, ready to fly. So it's a physical impossibility. Now, often when people talk about probability, they associate it with something called entropy. Now, entropy is a very scary word, but it's actually very, very simple. All the entropy tells you is how many ways something can happen. So if you look at, let's say, these 2 glass spheres connected by a tube, what happens is you can ask the question, how many ways could you have 4 balls on one side, or molecules, and 4 on the other? There's only 2 ways, right? But now if you ask the question, how many ways could you have 2 on one side and 2 on the other? There's a lot more ways to have it, right? So because there's more ways for it to happen, it's more probable, therefore it has higher entropy. So higher entropy just means there's more ways for something to happen. So a messy room has more entropy than a clean room, by analogy, because there's a lot more ways for your room to be messy and to be neat. That's the idea. Now, many have said that means that it's impossible for life to form because life represents a low entropy state, and nature always goes from low entropy to high entropy. Well, that argument is incomplete for the following reason. There are things that actually go to low entropy states. So for instance, water. What has more entropy, more disorder? What is there? Is it more easy to happen if all configurations of molecules are equally probable? Well, obviously water, because water, there's a lot more ways to get water than to get ice, right? Ice is very rare, it's configurations of molecules. But we do get ice. When the temperature freezes, you get ice. Why does that happen? Well, the reason that happens is because the attractive forces between hydrogen and oxygen pull the molecules together in that configuration. So not all states are equally probable. Let me use an analogy. If I came to you and I had 2 dice, and I said, I bet you $1,000 that I could roll 100 sixes in a row, and you don't know me, I just came off the street, who would take me up on that bet? 100 sixes in a row. I bet you I can do it. Who would take me on that bet? Well, most would not. Why? Because the dice would be loaded, and I would win the bet. So nature prefers states of low energy. That's why water freezes. It's low entropy. It's low energy. And that's a situation, because nature wants to do one of 2 things. Either it wants to go to greater entropy, or it wants to go to lower energy. But here's the problem. Origin of life is kind of like this. Imagine you try to roll 1,000 sixes in a row, and the dice are loaded against rolling even 1. That makes it even harder. In the same way, the origin of life requires that simple chemicals go to a state of very, very low entropy and to a state of very, very high energy. That's a physical impossibility. Nothing in the universe ever does that. So what happened is there is actually a physicist. His name was Harold Morowitz. He calculated what's the probability for simple chemicals on the Earth to turn into a cell. He said the probability was going to be on the order of 1 part in 10 to 100 billion. That's a 1 with 100 billion zeros around it. That's really, really small. In other words, it's not going to happen. So what it seems like is the laws of physics would prevent life from ever happening. But what happened is people said, okay, maybe that's true in normal circumstances, but what if your system was very, very far from equilibrium? Like if you just shoved it full of energy, maybe something new could happen. In fact, how many of you have ever seen like what's called Rayleigh-Benard convection? That's like you boil water and you notice those roll patterns? That's pattern formation, that's order formation due to a system that's driven with energy. Another example is a tornado. You have mass and energy in the right states, and a tornado cloud, a funnel cloud, spontaneously forms. There's also what's called the BZ reaction, where you have these chemical patterns that form because you're feeding the system with highly reactive chemicals. That's called self-organizational order. And people said maybe in the same way, if you've got some pool of chemicals and you're just bombarding it with energy, maybe it's a solar flare, maybe it's a thermal vent, who knows? But if you just throw this thing far from equilibrium, maybe you can get the order necessary for life. That's the basic idea. Well, the problem is, what you find is that the order in these self-organizational systems is completely the opposite of the order you want in life. The order in these self-organizational systems, it's large scale, it's dynamic. The order you want in life is microscopic order, low entropy, and it's called specified complexity. You've got very specific arrangements of molecules that achieve a functional goal. So what happens is people realize that the order that you see in these self-organizational systems is completely different from the order of life. In fact, there was some research done by Jeremy England from MIT, and he was looking at what are called fluctuation theorems. Don't worry about the technical details. But what he found is that even systems driven far from equilibrium still tend towards to higher entropy, and they still tend towards states of lower free energy, which give off heat. So that's it. They tend towards higher entropy, they tend to give off heat, which is the exact opposite of what you want with life. So he figured that the probability, if you look at his calculations and you actually follow his math, I did the math, you find that the chance of life forming, even driven far from equilibrium, is still about 1 in 10 to the power of 100 billion for like an E. coli scale. In other words, it won't happen. So basically what happens is the origin of life cannot happen by natural processes because it violates the most fundamental laws of physics. Now, the question then becomes, how do you get life? Before I get into that, I want to give you a simple analogy because I don't want to scare you with all the technical language and equations. Whoever has been in a library when they're sort of putting up books and there's lots of books on the floor? Now, what happens is entropy would be like books thrown everywhere. That's lots of disorder. Energy would be like the shelf that you put the book on. So a high shelf is high energy, a low shelf is low energy. So a cell forming is like all the books on the top shelf in alphabetical order. That's the situation. Now the question is, if you just added energy to the library, would that tend to create books that are highly ordered on the top shelf, or would it tend to take books and throw them on the floor in random patterns? So adding energy, if there's like an earthquake, might take a few books and bump them up to the top shelf, but in general, it's going to dump books from the top shelf to the bottom shelf and mix everything up. That's just more of a simple analogy. So the question is, how do you get life? Like life obviously reproduces, right? How does that happen? Well, to have life, you have to have machinery and information. And let me explain that to you with a simple analogy. Let's imagine you heard you can get order for free from energy. That's what you hear all the time in Origin of Life. Order for free from energy. So you think that's great. You come to your house is a complete mess. So you ask, how can I order my house? Well, maybe I take gasoline and pour gasoline on the couch and set the couch on fire. Maybe the energy from the fire will order my house. Will that work? No, that's not going to work too well. You're going to get more of a mess if that happens. So you think, okay, that's fine. What I need is machinery to convert one form of energy into another. So you buy a robot off eBay or Amazon, and that robot has an engine, so it can convert gasoline or solar power or electricity into mechanical energy, and that mechanical energy might do something useful. But if you bought your robot off of Amazon, you plugged it in, you fired it up, and you just let it run loose in your house, would that help? No, that probably wouldn't help too much. What would the robot be missing? Instructions. The robot needs information. It needs the program to tell it what to do. So one line of program would say, mop the floor. Another one would tell you how to wash a dish. So you need information or instructions to direct the energy in a way that produces the order that you want. And the same is true in the origin of life. Because what happens is normally if you have, let's say, a cell that's forming, and let's imagine you hire a bunch of biochemists, a bunch of organic synthesis experts, and you create, let's say, half of a cell. It's halfway there. You have half the proteins, half the nucleic acids, you got the cell membrane. What's going to happen? Natural processes will break apart the cell and turn it back into simple chemicals. It's going to go towards equilibrium. All natural processes move away from life, not towards life. So what you want is what's called homeostasis. That's a state where you've got your cell, which is a confined environment that's pulled far from equilibrium. You have chemicals that are very different from what's in the surroundings. So the only way that can happen is if you've got machinery, you have to have some sort of machine here, and that machine takes energy in of some sort, it produces waste, and then it will take that energy and it'll direct that energy in such a way to drive all the chemical reactions you want and to maintain your homeostasis. So you need machinery for that to happen. Now in cells, you have very complex machinery like ATP synthase, you've got like chloroplasts that can process energy, you've got complex metabolic pathways. Well, what's happened is the state-of-the-art origin of life research is trying to figure out what natural process could mimic those engines. Like what in nature could actually process energy and give it to you in a form that could be useful for life. And the most advanced research is by Nick Lane, who's talking about these hydrothermal vents. And these hydrothermal vents are essentially vents where you've got an acidic ocean, very acidic, you've got an alkaline vent, and you've got a cell membrane, and hydrogens pass through that membrane, or perhaps electrons, and that gives you free energy that drives chemical reactions. That's the best that's out there. Well, if you look at what happens with the origin of life, what has to happen is you have to have simple chemicals that are being driven out of equilibrium towards a cell. And the more you move towards the final state of a cell, the more you move out of equilibrium, and the more nature is trying to push you back towards equilibrium. So the closer you get to a cell, the stronger the push is back towards equilibrium. And what happens is once you get near the cell, the energy that you need produced in a cell is like 1 watt per gram just to maintain itself, just to fight the forces trying to pull it back. That's like a sports car. So the energy density of a cell is like a sports car. While the experiments I just talked about, the hydrothermal vents, the experiments have suggested they can only produce about 1 billionth of the power that's needed to help a cell even maintain itself far from equilibrium. And it's what happens is actually none of that energy can actually go towards the origin of life. So basically the idea that some natural process is going to generate the energy you want is like, again, a tornado through a junkyard producing a jet engine that could fly a plane across the Pacific. Not going to happen. Well, the problem is even if you had, let's say, engines in your cell, you give the engines that produce all the high energy molecules you want, all the energy you want in whatever form you want. That's still not helpful, and here's why. The question becomes, how do you direct the energy to drive the chemical reactions you want? Because if you look at the simplest viable cell, the minimally functional cell, you have this network of chemical reactions that produce all your building blocks, they assemble it, there's feedback control systems, et cetera, et cetera. So you're dealing with hundreds of reactions that have to be perfectly timed at the right strength for a cell to work. The problem is the chemical reactions in a cell require different environments. They require different chemical conditions. They cannot happen in the same place at the same time. That's a major problem. So how does life do it? Well, the way life does it is life has very, very complex chemical molecules called enzymes. What these enzymes do is they actually will grab the right molecules and force them together to produce the right chemical reactions. They're like little mini factories. So every chemical reaction in a cell is controlled by these enzymes. And what the enzymes also will do is they will take the energy from some chemical like ATP, and it'll take the energy from the breakdown of like that chemical and use it to direct the chemical reactions in the right direction. Because many of the chemical reactions in life cannot happen spontaneously. They go downhill. You need the energy from like your ATP to push them uphill, and the enzymes supply the energy to put the reactions uphill. So what is this like? Well, this goes back to my analogy. So what happens is in your cell, you have an engine, like your ATP synthase. It's producing lots and lots of high energy molecules. What happens is the enzymes are what's directing the chemical reactions you want, and they're also accessing the energy you want. But enzymes basically have what's called information. What is that like? Because what takes place is the enzyme is a protein, and a protein is a long string of amino acids. So you have about 20 amino acids, and those 20 amino acids are strung together like the letters of a sentence. So you have to have these amino acids in the right order. That's the information for the enzyme that causes it to fold into the right three-dimensional structure, which drives the right chemical reaction. So remember I talked about how you have to give your robot instructions? Each of these enzymes is just like one line of computer code that you would give to a robot. So the information, the enzymes, is basically the information that allows the right chemical reactions to take place. That's what's key. Now, why is it significant? Well, if any of you had alphabet soup, well, imagine that you're not feeling very well, your mother comes to take care of you, and she makes some alphabet soup for you. So you go up to your room, you come back, and you see this message that says, drink plenty of fluids and rest until you are feeling better. Now, how many of you think you could explain that message by the chemistry of the pasta? Or the physics of the boiling water? You would not, because whenever you see information, information is only the product of a mind. And to point to the information in the soup and point to intelligence is not appealing to the concerned mother of the gaps fallacy. That's a logical conclusion because information always points to design, which is what you see in cells. And when you look at a minimally functional cell, the amount of information that's necessary is equivalent to the information in a Christmas carol. That's how much information you need at the very start of life. That's what's key. Now, there's another thing also, because what happens in cells is I've talked about how you've got these enzymes, these proteins, and they are what cause the right chemical reactions to take place. The problem is all of these enzymes break all the time. So you have to keep replacing them, but proteins don't self-replicate. So you have to have a very advanced machinery in your cell that creates the new proteins, that replaces the parts. So you have to store the information someplace, and what happens is the information is encoded into DNA. Because what happens is every amino acid, like alanine or arginine or something like that, is connected to 3 letters in DNA, 3 nucleotides. So in the same way, if you're a computer programmer, you know that if you type a sentence, it gets encoded into 1s and 0s. In DNA, what happens is the sequence of amino acids in your enzyme is encoded into not 1s and 0s, but A, T, C, and G, the 4 letters of your genetic code. So the information in your proteins is encoded into the sequence of letters in DNA in the same way that you have like Morse code. Like in Morse code, you've got letters and they're converted to dots and dashes. Well, here's a problem. You have to then, after you encode it, you have to decode it. But the problem is there's no chemical connection between the amino acids and your set of 3 nucleotides called a codon. So if you were to have a giant vat and you threw in all your nucleotides, and then you threw in your amino acids, you would not see the codons connect to the amino acids. There's no chemical connections. So what that means is the information has to be encoded in DNA separately from the information being encoded into the proteins. You're seeing the same information encoded twice. It'd be like if you have your alphabet soup and you saw a sentence in English and then you saw the same sentence in German. That's even more extraordinary, and that's really what you're seeing in life. And here's actually the code that shows you how each amino acid corresponds to a set of 3 nucleotides, a codon. And there's multiple codons for a given amino acid. Now the problem is there are like 10 to the 84 ways you could associate your amino acids with your sets of nucleotides. An enormous number of ways you can make this happen. Yet there's no physical connection between the amino acid and your codons, your 3 nucleotides. That's a serious problem, because even if by some miracle all of the sequences in your proteins, your enzymes, were encoded into DNA, and by some miracle some process would decode them, the encoding and the decoding would almost always use separate codes. Because if the codes aren't aligned, it won't work. If you're using Morse code on one end, but the person tries to decode it with a different code, it's gibberish. So you have to have this code from the beginning. And what's clear is information and codes have to pre-exist the cell, and then you have to have the enzymes, the proteins, the DNA, all at once. Now, the only place you can have information in a code outside of physical reality is in a mind. So when you look at the nature of life, you see evidence of intelligent agency. Now, the obvious question, is design detection scientific? Is it scientific to say we see evidence in nature of design? Well, let me use an analogy. Any of you ever see the movie Contact? Yeah, it's sort of this movie with Jodie Foster, and what happens is she is studying extraterrestrial life. So she's looking at these signals from outer space and trying to figure out, is there information in those signals? And she actually comes across a signal, and that particular signal, it was different from this. I think that's from the Matrix. But there is a signal, and the signal actually encoded a spaceship. Now, is it scientific to say that she is seeing evidence of alien intelligence? Or is design detection unscientific? Should she assume it was produced by self-replicating quasars or cosmic radiation? Would that be better? No, because when you see evidence of information and machinery, you're seeing evidence of foresight, coordination, and goal direction, which are all evidence of design. In the same way, when you look at DNA, and particularly the DNA that was necessary in the first cell, you're seeing a signal, not a signal from space, but encoded information in the nucleotides of the DNA. That's information that's encoded for the cell. So just like the signal from space, which showed information, DNA shows information. And when you look at a minimally complex cell, what's happened is engineers from NASA asked the question, what do you need to create a self-replicating space probe? Like, what are the minimum requirements for self-replication? Also, people have looked at what is the minimal complexity you can have a cell and for it to still function. And this research has converged, and it shows that self-replication requires information processing, information production, manufacturing, auto-assembly, feedback control, automated repair, boundary with control gates, and self-replication, which brings it all together. All of this shows clear evidence of foresight, coordination, and goal direction, which are all evidences of design. So in the same way the signal from space pointed to a designer, when you look at the minimal requirements for the origin of life, you see the evidence of a mind that created a blueprint for the cell, which pre-existed the cell, and then it was implemented in time and space for a cell to work. In other words, clear evidence of a designer. And that's significant, because the biggest question in life is, what's my purpose? What's the nature of reality? And if we're simply an accident of nature, life has no purpose. We'll simply die, cease to exist, and nothing really matters. But if we're the product of a creator, that means we need to know our creator, know our purpose, and that's the only way for life to be meaningful. Thank you.